Welcome back to G Fun Facts Online. Today, we are bypassing the usual introductory fluff to dive straight into one of the most significant architectural shifts in the history of computer science. If you follow artificial intelligence, you know that for the last decade, we have been living in the era of the transformer. This is the architecture introduced by Google in 2017 that gave us ChatGPT, Claude, and Gemini. It is a statistical miracle that mimics human creativity. But recently, we have hit what engineers are calling the transformer ceiling. We are witnessing a massive paradigm shift from probabilistic generative models, which function like parrots, to deterministic intelligence, which functions like reasoners. In this episode, we are going to dissect this shift, looking at the limitations of current LLMs, and then detailing the new architectures like Titans, Mamba, and Neuro-Symbolic hybrids that are building the future of the glass-box AI. Let's start by diagnosing the patient. To understand why we need a successor to the transformer, we have to understand the fatal flaw of the current systems. At its core, a transformer is a sequence predictor. It relies on a mechanism called self-attention. When you ask it a question, it does not query a database of facts or perform a logical derivation. It calculates the statistical likelihood of the next token, or word fragment, appearing after your query. This leads to what we call the next token fallacy. The model cannot distinguish between a verified fact and a high-probability fiction. If the training data contains enough science fiction novels, the model might assign a non-zero probability to a fictional character walking on the moon. It creates a hallucination, which is just a polite term for a probabilistic error. This architecture also suffers from the reasoning gap. Transformers struggle with multi-step logic. If A implies B and B implies C, a human inherently knows that A must imply C. A transformer, however, often fails this transitive property if that specific connection wasn't explicit in its training data. It attempts to pattern match the logic rather than executing it. A famous example of this is the reversal curse. An LLM might know that Tom Cruise's mother is Mary Lee Pfeiffer, but fail to answer the question, who is the son of Mary Lee Pfeiffer? This is because the statistical probability flows strongly in only one direction in its training set. Furthermore, we have the context window bottleneck. Even with context windows reaching 1 or 2 million tokens, this is merely a buffer, not a memory. The model sees the data, but it doesn't learn from it in real time. Once the chat session ends, that knowledge is evaporated. This lack of persistence makes true, compounding intelligence impossible. Enter deterministic intelligence. This is the solution. Deterministic intelligence represents a move from purely probabilistic System 1 thinkers, which are fast, intuitive, and error-prone, to System 2 architectures, which are slow, logical, and verifiable. Deterministic AI implies systems that can guarantee their outputs based on verifiable logic, causal relationships, and persistent state. The core tenets here are reproducibility, verifiability, and test-time learning. Given the same input and state, the system must produce the exact same output, something current LLMs fail at due to temperature sampling. Crucially, the system must be able to prove why it reached a conclusion, citing specific logical steps rather than just opaque training weights. We are already seeing the industry pivot to this, with models like OpenAI's O1 or Strawberry, which introduces reasoning tokens. These are hidden chains of thought where the model talks to itself to verify its logic before answering the user. But this is just a software patch on a probabilistic engine. True deterministic intelligence requires new hardware of thought. This brings us to the most exciting developments at the architectural level: Google Titans and Mamba. Let's look at Titans first. Introduced by Google DeepMind in late 2024, Titans is a neural long-term memory architecture. It addresses the amnesia problem. Standard transformers reset after every session. Titans, however, introduces a neural memory module that sits inside the model. It uses a mechanism based on a surprise metric. When Titans processes new information, it calculates a gradient of surprise. If the information is new or unexpected, it updates its internal memory weights instantly. This is the difference between reading a book and forgetting it, versus reading a book and physically updating your brain to remember the plot forever. This memory retrieval is not a probabilistic guess. It is a learned state allowing for persistent agents, AI employees that remember your instructions from 6 months ago without needing them refed into a context window. Parallel to Titans, we have the rise of Mamba and state space models, or SSMs. While Titans focuses on memory, Mamba reimagines the flow of data. Transformers suffer from a quadratic complexity problem. They get exponentially slower the longer the text is, because every token has to look at every other token. Mamba uses a control theory approach with linear complexity. It maintains a hidden state that evolves over time. The breakthrough in Mamba is a mechanism called selectivity. The model can deterministically decide to ignore irrelevant noise and focus purely on critical state data. Think of Mamba less like a text predictor and more like a CPU with a register. It can hold a variable, say x equals 5, in its state across thousands of tokens of unrelated text, and then recall it perfectly when asked to print x. Transformers notoriously struggle with this needle in a haystack variable tracking, but for Mamba, it is architecturally native. We are also seeing the return of recurrent neural networks with XLSTM, developed by Sepp Hochreiter. By using exponential gating and matrix memory, XLSTM allows for massive memory capacities that were previously impossible for older RNNs, allowing the system to store complex relational structures deterministically. But hardware is only half the battle. If Mamba and Titans are the body, Neuro-Symbolic AI is the mind. This is the explicit fusion of neural networks with symbolic AI. Historically, neural networks are good at fuzzy things like vision, speech, and intuition. Symbolic AI is good at crisp things like math, logic, rules, and constraints. Neuro-Symbolic AI creates a loop between them. First, neural perception sees the world or reads a math problem. Second, symbolic translation converts that problem into a formal language like Python or Lean. Third, a deterministic solver, logic engine, or theorem prover solves the problem. Finally, neural explanation translates the answer back into human language. The poster child for this approach is Google DeepMind's AlphaGeometry. This system solved International Math Olympiad geometry problems at a gold medal level, surpassing human experts. It achieved this by using a language model to generate creative guesses, such as drawing a new line on a triangle, and then using a symbolic deduction engine to rigorously prove if those guesses worked. The symbolic engine is 100% deterministic. It cannot hallucinate. If it says a triangle is isosceles, it is isosceles. This effectively eliminates the black box problem for high-stakes reasoning. Deepening this logic is the field of automated theorem proving, revolutionized by hypertree proof search. Inspired by AlphaZero, this method explores the tree of possible logical steps. Instead of guessing the next word, it guesses the next logical tactic. It includes self-correction baked into the architecture. If a logical path leads to a contradiction, the system prunes that branch, unlike LLMs, which often double down on their errors. Underpinning all of this is a move toward more rigorous mathematics, specifically category theory and causal AI. Deep learning has historically been like alchemy. We throw data at a matrix and hope it learns. Category theory, specifically topos theory, is attempting to turn this into chemistry. It focuses on compositionality, where complex systems are built from simple, reusable modules or morphisms. Researchers are mapping neural networks to these categorical structures to mathematically prove that a neural network will behave a certain way. This is coupled with causal AI, championed by researchers like Judea Pearl. Current AI operates on association, seeing that smoke and fire are correlated. Causal AI moves to intervention and counterfactuals, asking what would have happened if I didn't light that match. Structural causal models encode the direction of relationships, distinguishing between correlation and causation. This is critical for enterprise utility. In banking or healthcare, you cannot use a correlation engine to decide loan approvals or cancer treatments. You need to know the cause. So what are the implications of this shift? We are moving from chatbots to industrial reasoning. First, we will see the death of prompt engineering. Prompt engineering is a symptom of probabilistic failure. We have to coax the model to be right. With deterministic intelligence, we move to spec-based engineering. You define the logic, the constraints, and the goal, and the system executes it reliably. We are also seeing the rise of sovereign operating systems, or SROS. These are frameworks designed to lock the state of AI, making the thought process as reproducible as a computer program. This is essential for auditability in legal and financial sectors. Furthermore, the paradigm of coding assistance will shift. We will move from copilots that suggest code you have to debug, to verifiers that write formally verified code. Tools like Vecagen are already using LLMs to write code alongside the mathematical proof that the code is bug-free. This is the holy grail for cybersecurity. Ultimately, the future is not deterministic versus probabilistic. It is hybrid. We will likely see architectures where a System 1 transformer handles the user interface, natural language, and empathy, while a System 2 Neuro-Symbolic core handles the logic, state management, and execution. Imagine a medical AI where the transformer listens to the patient's symptoms with empathy, the causal model builds a diagnosis graph based on logic, the Titan's memory recalls the patient's history from a decade ago, and the transformer then explains the diagnosis back to the patient. The transformer era was the age of the black box, magical, powerful, but ultimately unknowable. The deterministic era is the age of the glass box. By integrating the infinite memory of Titans, the state precision of Mamba, and the rigorous logic of Neuro-Symbolic AI, we are building machines that don't just guess the truth, they know it. This is not just an upgrade, it is the maturity of artificial intelligence. Thanks for listening to G Fun Facts Online.